Now, when we talk about solubility, we're talking about ionic compounds. So a compound made up of a metal and a nonmetal. When they dissolve in water. For example, I have this little drawing here. If we have the ionic compound NaCl, sodium chloride, if we took a bunch of that sodium chloride and poured it into water, what will happen is the compound will break down into ions. So in here, in this solution, we have Na, sodium plus ions, and Cl minus, the chloride ions. And they separate into those ions, and they're just floating around, separate from each other. And that happens because soluble ionic compounds are strong electrolytes, meaning that they'll completely dissociate into ions. And to know when that happens, the solubility rules, the solubility rules are the way to know that. So some compounds will always be soluble based on what's involved in the compound. For example, the alkali metals are always soluble no matter what. On the other hand, sometimes those compounds will be insoluble and they won't dissociate like this. They won't break into separate ions. They'll stay together as a compound. And things like lead and barium are often insoluble. And so it's important to know the solubility rules so well that when you see a compound, you could say, oh, when that's in water, that's going to dissociate. Or, oh, that's not going to dissociate, that's insoluble. So if you saw 3 compounds, you should be able to tell whether that's going to be soluble or insoluble. So if you had Na3PO4, if you saw CaCO3, and you saw K2SO4, and you were asked if these 3 compounds were put into water, which will dissociate or break into separate ions, and which won't dissociate, which ones are insoluble. Based on the solubility rules, you'd be able to say, oh, sodium, Na, is always soluble, no exceptions. So that's going to be aqueous. And then you'd see in this compound, CaCO3, this carbonate is typically insoluble, and it's not with one of its exceptions. So that's going to be a solid. This third compound, you'd be able to see that potassium, again, is an alkali metal, and it's always soluble. And so that would be aqueous. So the more practice you have, and the more you can visualize what's happening with these soluble compounds, the better off you'll be. The better you'll be able to see, oh, this will be soluble or this won't be soluble. And it takes practice. And this becomes really important when you start to do things with precipitate reactions. So if you have 2 solutions that are dissociated like this, 2 clear solutions, and you pour them together, based on the solubility rules and what you know about solubility, you'd be able to say, oh, there will be a precipitate formed, or there won't be. A precipitate is it's what happens when two or more of the different ions in 2 different solutions come together and they start to form a solid. Together they're insoluble. And so when you pour 2 clear solutions together and you start to get a filmy or a cloudy appearance, a precipitate's forming. Now, and when you do that, often you won't know which one or which equation will be a precipitate equation and which won't be. For example, if you had just this given to you, AgNO3 aqueous added with NaCl aqueous, and you're asked to come up with the products, and you'd be able to do that. So based on the solubility rules, we'd know that these are both soluble, and in solution they're both broken down into separate ions. Now, to come up with the products, we'll take the metal of this compound and trade it with the nonmetal of this compound. So we'll have AgCl. So that will leave us with the metal of the second compound and the nonmetal, the polyatomic ion of the first compound. And so that'll give us NaNO3. Now the question is whether both of these are soluble, whether they're both insoluble together, or if it's only one, which one it is. Now we can look at this compound and we'll know that it's soluble. It'll be aqueous. Based on our solubility rules, the sodium is always soluble because it's an alkali metal. There's no exceptions. Now this compound, chloride, is generally soluble except for when it's with a few compounds. And silver is one of those compounds that makes it insoluble. So this will be a solid. So we will have a precipitate reaction when we mix these two solutions. Now, so that's one example. We'll try another one. So if we were given BaCl2 and that's aqueous as we begin, it's a solution, as well as K2SO4 in solution. We're asked to come up with the products. Again, we'll just switch partners. So the metal and the nonmetal, and then the metal and the nonmetal. And so our products will be BaSO4 as well as, and to balance the equation, we'll have a 2 KCl. Now as we look at that, based on the solubility rules, we'll know that this compound again is soluble, AQ, because the potassium is soluble and the chloride soluble, so together they're definitely soluble. Now as we look at the second reactant that we have, barium sulfate, we'll see that sulfate is typically soluble, but one of its exceptions is when it's paired with barium. So this will be a solid. Again, we have a precipitate reaction. And so as you practice with these and as you become more familiar with the solubility rules, these kind of questions and reactions that you run into, you'll be able to tell whether they are precipitate reactions, where they form a cloudy appearance in the solution, or whether all of the ions together can exist just as ions, soluble and dissociated. Now as you practice with the solubility rules, it's important to keep in mind that they only apply to ionic compounds. So don't try to apply the solubility rules to a nonmetal and a nonmetal compound, or to acids or bases, anything like that. Just when dealing with ionic compounds, with the solubility rules and precipitate reactions matter or form. And just keep that in mind.